Hello guys, this is Paul McWhorter from TopTechBoy.com, and I am here today with lesson number 10 in our new, our improved, our exciting tutorial series on the Arduino. One of the things we're trying to do in this series is we're trying to bring a little bit more math and physics into the lessons. We're trying to understand a little bit more about what's going on under the hood in the Arduino. What we are going to do today is we are going to learn how to read analog voltages using the Arduino. So I need you to pour yourself a nice big mug of iced coffee. Refreshing. That strong black coffee poured over ice. No sugar. None is needed. Try it. It's refreshing and it is delicious. So pour your coffee and then also get out your eLego kit, your eLego Super Starter Kit. If you haven't gotten one yet, look in the description, click on the link, hook a brother up, get it there. It's about 35 bucks, and we will be using this for this entire series of lessons. So we are going to learn a lot with that kit. But today, what we are going to learn is how to read analog voltages. Now, let's review the things we've learned in the earlier lessons. We've learned how to do digital writes, which is taking one of the output pins and setting it high or low. We've learned how to do analog writes, where we can sort of get the in-between voltages. And then we have learned how to do delays. So the things we've done so far have been sending signals to the Arduino pins. But today we're going to learn how to read from the Arduino pins, because you might have a sensor hooked to it and the value coming off the sensor might be a voltage. So you need to be able to read that voltage. And so analog read is a very important function. And to illustrate how to do analog read, we are first of all going to get out of your way, and then we are going to go back to that circuit that we built in lesson number 9. And in case you were not here for lesson number 9, if you get lost here about this circuit, go back and watch lesson number 9, or you can just kind of keep up with it here. But this is the circuit that we analyzed in lesson number 9. We got 5 volts off the Arduino. We then have resistor 1 at 330 ohms in series with resistor 2 of 100 ohms. And I showed you how to do the circuit analysis such that you learned that for this particular circuit, the voltage across resistor 1 is going to be 3.84 volts. The voltage across resistor 2 is going to be 1.16 volts. And then we built the circuit and we verified it worked with this most excellent Mastech digital voltmeter. The digital voltmeter is a great tool, but you don't want to have to go pull out your voltmeter every time you're doing a project, so you need to know how to read a voltage using the Arduino. So first thing I need you to do is, if you don't still have your circuit from lesson 9, I need you to build it real quick. It's very simple. Like we talked about here, you can pause it and build it. Your eLego kit has 100 ohm resistors and your eLego kit has 330 ohm resistors, so you can build it with the components from that. But we bring 5 volts off of the Arduino, the 5 volt pin, it's labeled 5V. We come over to column 15 of the prototyping board. Doesn't matter which one you use. We use column 15, but what does matter is the one leg of the resistor needs to be in the same column as the wire coming in. Then we go across the resistor. We're kind of driving through the circuit here. We go across the resistor. Second leg of the resistor is in column 20, and then column 20 also has the first leg of the second resistor, R2. Then we jump over this divot, don't jump over this ditch where there is not a connection, and then in the lower part of the column 20, we have the other leg of the resistor, and then we have this white wire also in that column, and then bring that back to the GND, or the ground. It's the pin next to pin 13 on the Arduino. And so when we probe this with the Mastech voltmeter, we see that we actually get the voltages that we anticipate. But now we want to ask, how can we measure these voltages using the Arduino? Well, what we want to do is we want to probe this point right here, that connection point between the bottom of R1 and the top of R2, and then that will allow us to know what the voltage is between this point and ground, which would be the voltage across R2, which would be V2, which we anticipate would be 1.16 volts. So we come over here, and this is the point right here that I want to connect, right? I'm connecting to the bottom of the first resistor and the top of the second resistor, and then I need to plug this wire into the Arduino. All right, now what pins have we used so far? The pins that we've used so far are the digital pins, pins 2 through 13. We can do digital writes to all of those, and then the ones with the squigglies, we can do analog writes to. We cannot read analog voltages from those. We need to read analog voltages from these pins on the other side, which are labeled A0 to A5. Any of those we can read an analog voltage from. So, just for fun, I am going to choose A3. So we will be working with pin A3 to make our voltage measurement. So I have it plugged in, and we are ready to read. But in order to read now, we need to do some coding. Okay, we need to do some coding. So we need to come over to our coding window here, and we need to start writing our program. So we will come up to the top, and what do we do at the top? We declare our variables. All right, so one variable we need for our pin. We use ints or integers for our pin names, and I'm just going to call this read pin, okay, because it's the pin I'm going to read from. And what is that equal to? That is equal to A3. We are setting read pin to A3. Don't forget your semicolon. Then I'm going to be reading a voltage from that pin. So I need a variable to read the voltage into. And what would be a good variable name? Well, what are we trying to find? V2. So let's call it V2. You can name your variables whatever you want, but just make sure that you name them something that is descriptive, like just don't call it XYZ or your cat's name or something like that. So I'll call this V2, and we'll just set that initially equal to 0 just to set the variable up. Okay, now we need to come down to our void setup. And what do we need to do in the void setup? Our pin modes, right? How many pins am I using? I'm using one pin, so I'm going to say pin mode. Which pin am I doing? Read pin. What is this different this time than all the other times? All the other times the pins have been outputs. We've been sending data to them or sending signals to them. They've been outputs. This one is an input. All caps, we get the happy little blue color. All right, so there we are. And then we come down here. And what do we want to do? We want to do an analog read. Okay, but when we get that value from that pin, we're going to go out to that read pin and we're going to get a value. We got to put it somewhere. Where do we put it? We put it in this variable V2. So how do we do that? We say V2 is equal to what? Analog read. And there's one parameter that you need for an analog read command, and that is where you're reading from. Where are you reading from? A3. A3. No, you don't use constants there. You always use your variables. What do we call it? Read pin, okay? And then we put our semicolon. All right, so this is going to sit here and it's going to loop and read analog read, analog read, analog read. And so it's going to be reading into V2, 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 V2. It's going to constantly be updating this V2. What is our problem now? We don't have any way to see it, okay, because you haven't learned how to do that yet. So in the next lesson, I'm going to teach you all about using Arduino print commands, where you can use the Arduino to print numbers to your screen that you can see. All kinds of exciting things to learn there, but I got to give you a little bitty preview. I have to give you a little tiny little preview in order that we can print out this V2 that we're reading here. So this is your quick mini lesson on how to do a print in Arduino. You need to come up to your void setup and you need to set up your serial monitor, and you do that with serial. Notice the capital S, serial, turns orange, happy little orange color, and then dot begin. Oh look, begin turned orange too, happy little color. Serial dot begin, it recognizes that, and then you need one parameter, which is the baud rate. That's how quickly you are going to be talking to your serial monitor. And 9600 is a good one. We can talk more about what the different baud rates are that you can use and the pros and cons later, but here Very simple. We're setting up our serial monitor where we can print to it. Now what we do is we come down here, and after we have read V2, we need to what? We need to print V2, and we do that with serial, happy little color, capital S, dot print ln. That means print a line. That means go to a new line. Each time you print ln, and then tell it what you want to print. What do you want to print? V2. Okay, so what is this loop going to do? You're going to read V2 from read pin, which is A3, and then you're going to print it, and then you're going to read it, and then you're going to print it. It's just going to read, print, read, print, reprint. What's one thing that might be a little problem? It's going to be reading and printing so quickly that you might not be able to see it, so we need to put a little delay in there. So let's say delay, you know this command, and then what would you say, about half a second? That would be 500 milliseconds, right? Are you happy? No, what did I just do? I used a constant down here. We don't use constants, we use variables. We need another variable up here at top, int, and we can call it delay time, like that. Okay, so now, and we can initially set that to what, 500 that we wanted. All right, so then down here, instead of putting in 500, we put in delay time, because we're going to be good programmers and we're going to be using variables and we are not going to be using constants. So what is our void loop going to do? It's going to read from read pin, which is pin A3, and then that's going to put it in the variable V2, and then we're going to print V2, and then we're going to pause. So it's like read, print, pause, read, print, pause, read, print, pause. Now we are going to download this into the Arduino, and we're going to hope that we get the happy little bar, and then we are going to download it. Hold your breath. Boom, it downloaded. Our code is correct, and so now we want to look at these values that we're printing. And the way that we look at it, we open the serial monitor with what looks like a little magnifying glass up here. You click on that, and then you will pop open your serial monitor, which can now be seen here. And look at that. We are sitting and we are reading values and we are printing values, and the number we are reading is 292. Houston, we have a problem because we could not be getting 290 volts out of the Arduino. Okay, I will explain it. The analog read does not read the actual voltage. It reads a scaled value of it, and it reads a number between 0 and 1023, okay? And that's like what? 1023 is what? Let me do that real quick. I should know this off the top of my head. You know, I should know this off the top of my head. That is a 10-bit number, okay? Because 0 to 1023, that is 1024 numbers, and 1024 is 10 bits. It's 2 to the 10th, okay? So that's how you end up with these strange numbers like 255 and 1023. Well, 1023, 0 to 1023 is 10,024 different numbers, which is 2 to the 10th. Okay, does that make sense? And so what you have to see is that if you had 0 volts, if you had, you can't see what I'm writing, can you? Let's go back over to a different view here where you can see what I'm writing. Okay, so if you had 0 volts, what would you read with an analog read? So this is actual voltage. If your actual voltage was 0, your read value would be 0. If your actual voltage is 5, your read value would be 1023. So let's see if that is really the case. And so what I am going to do is I'm going to take this wire from A3, and I'm going to hook it up here to the top, which is 5 volts, and then I am going to come back over to the other view. And what are we reading? Well, we're reading 1021. That means that this isn't quite putting out exactly 5 volts. It's a little short, but you can see that the 1023 would represent exactly 5 volts. Where can I also put the pin? I can put the pin to ground, and if I put the pin to ground, I am reading almost 0. And so again, it's not perfectly 0, it's 0, 1. Okay, now I am pretty much reading 0. So let's go back and look at our math. Okay, so would it help if I used a bigger pin? Maybe it would. Okay, so let's look at this and let's think about it. Let me get a little more paper here. So what we just saw is that 1023, 0 to 1023, this comes from the number 2 to the 10th. And so you see in computers, you always kind of end up in these things that are 2 to the something. 0 to 1023 is 1024 numbers, which is 2 to the 10th. We know that we have voltages, and then we have read values. Read is what we read. So if we have a voltage of 0, our read value is 0. If we have voltages of 5 volts, which is the maximum, we're going to read 1023. And so really, we need to do a calculation. We can't just print out what we're reading. We have to do a calculation. So what we want to do is we want to say voltage, and we'll call it voltage 2, which is what we actually want. That is equal to read val, that's what we're reading, times what? Well, 0 is 0, 5 is 1023. You can see that the slope is what? 1023 over 5. I did that wrong. It is 5 over 1023, right? It's y2 minus y1 over x2 minus x1, and so v2, I hate it when I'm writing and you're not seeing it. Let me get that out of the way. Okay, so v2 is 5 divided by 1023 times read val. Okay, so let's see if this works. If read val is 0, we put in 0, and 0 times 5 over 1023 is 0. That is correct. Let's say our read value is 1023. 1023 divided by 1023 makes 1 times 5 is 5. V2 is 5. So we see this works, that if we do this calculation, instead of reporting this strange, seemingly meaningless digital number that we're getting off of our analog read, we're converting it to a real and useful number. So let's come back over here, and remember, I've got this thing hooked up, right, to be reading from I've hooked it back up where I've got to keep my windows straight. I've hooked it back up where I am reading right here. I'm reading that V2 point, and then I will come back over here so you can see me program. All right, so what do we need to do differently on this program? Well, we need a new variable, and it's going to be int, and we're going to call it read val. Okay, and we don't have to give it here because we'll read it later. We'll just declare it and then it'll be happy. So I don't want to read into voltage because it's not voltage. I want to read into read val, and then I want to take read val and I want to turn it into voltage. What is that nonsense? What happened here? Okay, here we go. Okay, so I declare read val, and then down here analog read is not going to go into V2 because analog read is this strange read val. So I'm going to come here and I'm going to say put that number into read val. Now what I've got to do is I've got to calculate V2. What is V2? Go back and look, and we said that it was 5, and I'll explain this later, but you got to put a 5 point divided by 1023 point. Okay, you got to put your decimals in, and then times, the times is the little asterisk, and then times what? Times read val. So you read in read val, and then you multiply it by 5, and you divide by 1023, and then you get a real voltage, an actual voltage, and then you print that voltage out. Okay, let me explain just a little bit. Why do I have to put 5 divided by 1023 with points? In Arduino, if you just write the number 5 without a decimal, it interprets it as an integer. If you write 1023 with just as 1023, it evaluates it as an integer. And if you say one integer divided by another integer, what kind of answer is it going to give you? It's going to give you an integer. And 5 divided by 1023 in integer math is what? 0. This is one of the most common problems that I see when your program doesn't work. It'd just be printing 0, 0, 0, 0. Well, why would it be doing that? It would be doing that because you are doing integer math. When you put a point at the end, it makes it a floating point number, and then 5 divided by 1023 is going to be a nice floating point number of 4.89 e to the minus 3. Does that make sense? Okay, let's give this a try, and let's download it now. Oh, it is unhappy. What is wrong here? Oh, were you guys yelling at me? What did I forget to do here? I said V2 is 5 divided by 1023 times read val. What does it say down in the error? It is saying that it was expecting a colon before serial. I look here, what did I not put? I did not put my semicolon. Okay, let's try it again. Okay, we download it. Okay, and the voltage is coming out to be 0. Wonder what's going on here. All right, wonder what's going on here. Let's think about it. What did we declare V2 to be? What did we declare V2 to be? We declared it to be an int. And if we have something like 0.967, it's going to round off to what? 0. So this V2, instead of making that an int, it should have been a what? A float. Okay? Because now you can see that 5 divided by 1023 is going to be a floating point number. So we need to make V2 what? A float. Because you wouldn't just have 0, 1, 2, 3, 4, 5 volts. You would have the in-between voltages. So we need to make that a float. Okay, I hope when I did this you guys caught on, but I kind of do things sometimes to put mistakes in just to see if you're paying attention. All right, so let's download this. The suspense build. Look at that. Boom. 0.32, 0.32, 0.32, 0.32. Okay, so we are actually reading a voltage here, and this would be a real voltage. Okay, so what have we learned today? We've learned how to turn on our serial monitor. Okay, that is good. Well, why is this so small? Hold on. Okay, I got that in A3. I've got this here. I've got this grounded. I've got this set to 5 volts. I've got this. I am not getting a good reading. Let's see why. Okay, I'm sorry. I've got this hooked up wrong. Okay. Let me try again. This is hard to do work like this in real time. Okay, now it is working. Guys, I had the wire in there wrong, and that's why we were not reading the right voltage. Okay, so now we are printing out a real-world voltage of 1.18 volts. And so what that is saying is, if we come over here, if we come over, where am I? If we come over here, you can see that I'm looking at this voltage across R2 because I connected A3 into that connection between the two resistors, which is measuring this voltage right here across R2. And what did we say we expected that voltage to be? We expected that voltage to be 1.16, and right now we are reading 1.15. Boom! We have done an amazing thing here. So let's think about and review what we have learned. We have learned how to do an analog read. When we do an analog read, we do not read actual voltage. We read a scaled number between 0 and 1023. If you read 1023, you actually have 5 volts. If you read 0, you actually have 0 volts. So what you have to do is you have to take your read value and you have to multiply by 5, you have to divide by 1023, and then you get a real and actual voltage. And so we've learned how to do an analog read. We've learned how to convert that analog read into an actual voltage. We have learned how to do a pin mode for an input pin. We have learned that you do your analog read through the A0 through A5 pins. We have learned how to turn on our serial monitor, and we have learned how to print things from our serial monitor. And I find it just absolutely amazing that we are actually getting very good readings and very good voltages using this analog read. Okay, guys, this has been a fun lesson. We've learned something really new and important. Would love to hear your comments down below. Have you been able to get this thing working? Are you guys actually following along and building these things as I'm doing them? You know, I hope so. This is your assignment for tomorrow. What your assignment for tomorrow is to pick out 2 different resistors in the eLego kit. Like find 2 different resistors, like maybe there's a 10K and a 2K or a 10K and a 1K, and go through this whole exercise where you use 2 different resistors, go through the circuit analysis, predict what that voltage is going to be, and then come in and measure it. All right, and just show that you can kind of do this start to finish on your own. Okay, Paul McWhorter from TopTechBoy.com. I would really appreciate your comments down below. I would really appreciate you subscribing to the channel. Hey, I've been getting a lot of emails from people that have subscribed to the channel and saying, hey, I'm not getting the notification. There by the subscribe button, you need to click the bell and then you'll get notifications. Okay, Paul McWhorter from TopTechBoy.com. I will talk to you guys later. That is good coffee.